Luca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. So let me go ahead and start the recording. Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we'll be sharing today. Without further ado, I will hand it over to our presenters and post the link to the 1324 room.
Hello, everyone, and welcome once again for our Friday Happy Math Hour. So happy you all can join us. Let's take a few seconds to let some of you go to the other room if if you want the review or happy hour for the business math 1324, go ahead and click on the link on the side. Very well. Okay, so let's go ahead and get started. So today's math happy hour, we're going to do linear and nonlinear systems of equations. Okay, so let's do a little definitions and review of what a linear system is. Okay, a linear system is all equations that are in this form: ax plus by equals to c. Okay, and if we were to graph these, what we'd be graphing are lines. Again, the title, linear system, so we're going to be graphing lines, and instead of just graphing one line at a time, what we're going to do is we're going to graph several lines at once. Okay, so a system is composed of more than one line, and these are the variables that are mostly used: the a, b, and c, and d, e, and f when we have more than one. Okay, so a solution for a linear system is going to be an ordered pair. We will have a solution if the lines intersect. Okay, and we'll cover this. A solution set is a set of all ordered pairs that satisfy both equations, and we will see this when we're looking at similar lines. All right, so a system can be a system with only linear equations or a system with nonlinear equations. So we'll start with linear equations, just graphing lines at the same time. But with nonlinear equations, what that means is we'll also look at a quadratic, a parabola with a line, or a circle with a line. So that's what the nonlinear equations are. So we'll look at those and we'll see the solution sets for those as well. Okay, there are three basic ways to solving linear systems, and we're going to cover all of them. There is one called the substitution method, the elimination by addition, and graphing. Okay, so the solution is the intersection of these graphs. Where these lines intersect, that's going to be our solution sets. Okay. All right, so to find a solution, we can do it graphically, which is the easiest way to see if a linear system has a solution, is by graphing them. So if we look at our first graph here, okay, we have two lines, and if we see that these two lines intersect at this point, so this 2, 0 means that this point is a solution for both of these equations. If I would put 2 for x on this equation and 0 for y on this equation, it's going to give me the value 1. Same thing with the second equation. If I put 2 for x on this equation and 0 for y on this equation, the answer is going to give me 2. So this solution point is valid for both of these lines. Now, this is an example of an equation with a nonlinear equation. So we have a line here, and then we have a quadratic, a parabola. Our graph is a parabola. So you see that this line will cross at 2 points on our graph. So these 2 points, the 2.1, the 2, 1, excuse me, and the 0, -1 are solution points for both of these equations. Now, when we're looking at our graph here, this graph that's why we use graphs to see if we have a solution set, and we can tell on this particular graph that these two graphs don't intersect. This line just never crosses parabola. So this two equations have no solution points. Yes. So on your computer, we would write no solution because they don't intersect. All right, so let's practice. Determine whether each ordered pair is a solution of the system. So what we want to do is we want to plug in these 2 points. This is the x value, this is the y value, and we're going to plug these values into the first equation and into the second equation. And if they both give us these answers, then it is a solution point for the system. So let's go ahead and do A first. Okay. So for A, when we plug in 0 for x on the for the for the first equation and 0 for y on the second equation, okay? So we have 2 times 0 minus a negative 4. So 2 times 0 is 0, a negative with a negative is a positive 4, so it's equals 4. So the 0, negative 4 is a solution for this first equation, but we got to make sure to check if it's for the second. So when we plug it in for the second, 0 for the x, negative 4 for the y, we see that we get a negative 4. And negative 4 is not equal to negative 9. So this point is not a solution for this linear system. This point had to be valid for both equations in order for the system to be true. So if it's only good for one and not good for the other, then this point is not a solution set for this system. Let's do B, the same scenario, okay? So we see that when we plug in negative 1/2 for x and negative 5 for y for the first equation, it does match. We get an answer for 4 equals 4. So this is a solution. Let's try it for the second equation. So when we plug in for the second equation, x equals negative 1/2 for x and negative 5 for y, we see that it does match. Negative 9 equals to negative 9. So in this particular case, this solution point is a solution for this linear system because it matches for both equations. Okay. All right, to solve equations using the substitution and elimination method. So one thing that I want to mention is we're going to teach you both, okay? But I always tell my students, always use the method that you're more comfortable with, because both of them will give you a way to solve linear systems. There's one easier for another depending on the equations that they give you, but always do the one that you're more comfortable with. So let's go ahead and give you an example for the substitution method. So the substitution method, just like the name suggests, is you're going to solve for one of the variables in one of the equation. And in this case, we're going to solve for x. And what we're going to do is we're going to substitute this answer, 4 minus y, into the other equation. Okay? So again, that's where the name substitution comes in. We're going to substitute it into the other one. So we substitute x by 4 minus y, and then we're going to solve now. When we solve, we get the y equals 1. So now that we have one of the variables, you can substitute this answer into either of these two equations. Normally, I always like to pick one that I haven't touched, so like the first one, okay? So what I would do is I would replace the 1 into the first equation. So x plus 1 equals 4. Solve for x, so subtract 1 on both sides. So I have x equals 3. So this is the substitution method. So let me show you the elimination method, okay? The elimination method, and the solution set is this point, 3, 1. We had the value for x was 3, and the value for y is 1. And if I would plug these 2 points into these equations, we would see that they did match. Okay, so let's go ahead and do the elimination method. All right, so to do the elimination method, we're going to choose a variable to eliminate. Now, on this particular case, since I'm going to choose y, and the reason why I want to choose y is because I know that if I were to add these two methods together, or these two equations together, we would see that the y's cancel, and that's why it's called the elimination by addition, because you're going to be adding the two equations together to eliminate one of the variables. Okay, so look what happens. If I just add them without having to do anything, if I just add equation 1 with equation 2, what it's going to result is by me losing the y variable. They cancels out. Plus y minus y is 0, so it cancels out. Then we have x plus x is 2x, and 4 plus 2 equals 6. So now just to solve for x, I divide both sides by 2, and x is equal to 3. Okay, then I just do the same thing as I did for my substitution method. I replace this 3 with any of the two equations to solve for y. So again, I'm choosing the first equation again. So x plus y equals to 4. I solve that x is equal to 3. So to solve for y, I'm going to subtract 3 on both sides. So y is equal to 1. So as you can see, both of these gave me the solution set 3, 1. Now, again, I always recommend to use the method that you feel more comfortable with. Both of them will work all the time. Okay? All right. So let's go ahead and practice, and let's solve the system using any method that you want. So what I'll do is I'll give you a few seconds so you can write it down and choose a method, and then we'll go through both methods and we'll solve them to verify our work. Okay, give you a few seconds to do this. All right, so let's notice that what we see is on this first equation, they already have it solved for y. So let's go ahead and use the substitution method. Since they already did some work for us, let's go ahead and use that method. So what I'm going to do is y is equal to 2x plus 3. I'm going to substitute this value into the second equation. Okay, so my second equation is x plus 2y equals -4. So everywhere I see y, I'm going to plug in this 2x plus 3. Okay, and then I'm going to distribute that 2. So I'm going to have x plus 4x plus 6 equals -4. And then let's go ahead and combine my like terms. I have an x plus 4x is going to give me 5x. And then what I'm going to do is going to move the number to the other side. I'm going to subtract 6 on both sides. So -4 minus 6 gives me a -10. So to solve for x, I'm just then going to divide by 5 on both sides. So x is equal to -2. So now that I have one of the variables, all I have to do is replace it to one of my two equations, doesn't matter which, to solve for my y variable. Okay, so now I'm going to do what's called back substitution. So everywhere I see x, I'm going to plug in the -2. And if you can see, I chose my first equation again. So 2 times the -2 is going to give me a -4 plus 3 equals y, and -4 plus 3 equals -1. So my solution set is -2, -1. And again, and if I would plug in these two values into both of these equations, they will give me a solution for both. Okay, they will match. All right, so let's try it again. Let's practice. As you can see, let's continue practicing our substitution since, again, they went ahead and solved for y for one of them. Let's go ahead and do again the substitution method. Okay, so again, since I have y equals 2x minus 3, I'm going to replace it to the first equation. Everywhere I see y, I'm going to replace it with this information. So we have 3x minus 2 times 2x minus 3 equals 7. So I'm going to distribute my -2. So -2 times 2x is a -4x. -2 times a -3 is a +6. Combine my like terms. 3x minus 4x is a -x. Move my 6 to the other side by subtracting 6 on both sides. So 7 minus 6 is a 1. But I want to solve for x, so you can either multiply by -1 on both sides or divide by a -1 on both sides. And when I do that, x is equal to -1. And then I'm going to do back substitution again. Everywhere I see x, I'm going to plug it into the equation. And on this one, I'm choosing now the second equation because that's already solved for y. So we have 2 times -1 is a -2, and -2 minus 3 is a -5. So my solution set for these linear system is -5, -1. Yes? Any questions, please feel free to ask me, okay, if I'm going too fast. All right. Let's look at this one. Ooh, they didn't solve for y or x on this one. So on this one, we can choose any method that we want, but for practice purposes, let's go ahead and do the elimination by addition method. So we first need to choose a variable to eliminate. Now, I always like to choose one that's easy, but on this one, they're both equally, I guess, difficult or easy, however you want to look at it, to eliminate. So let's just go ahead and eliminate x. So for us to eliminate x, okay, they need to have the same value but opposing signs, right? They have to be a different sign in order for us, when we add them, they want to cancel out. So we also want to make sure that you want to use small numbers. So we want to use the least common multiple between 2 and 5, right? So in our case, it's going to be 10. So for us to do this, what we want to do is we want to multiply the first equation by 5 and the second equation by 2. And both of the numbers that I'm going to be multiplied are positive numbers. And the reason why I can do that is because the second equation also already has a different sign. The second equation is already negative. It's ideal for the subtraction. Okay? All right. So let's go ahead and do this separately. Let's go ahead and multiply the first equation by 5. So when I do this, I'm going to have 5 times 2 is going to give me 10x. 5 times a -7 is a -35y. And the 5 times 3 is 15. Now, it's very crucial that when we are doing the addition by elimination method, that when we multiply a number to equation, we multiply that number to the whole equation, to both sides of the equal, okay? Don't just do one side. Make sure you multiply it to both sides of the equation. All right, let's do the second equation. The second equation, we're multiplying by 2. So 2 times a -5x is going to give me the -10x. 2 times the 3y is a 6y. And the 2 times 7 is 14. So now I have my new two equations. I have 10x minus 35y equals 15, and -10x plus 6y equals 14. So the elimination method asks us to add these two equations together. And when I add these two equations together, my x's are going to get eliminated. So 10x minus 10x is 0. Minus 35y plus 6y is a minus 29y. And 15 plus 14 equals to 29. So to solve for y, I'm going to divide both sides by a -29. So 29 divided by a -29 is a -1. So now I'm going to do back substitution in order for me to get my x. Now it doesn't matter again which equation I choose. It doesn't matter. I can choose the first or second. In this case, I chose my first again. So everywhere I see y, I'm going to plug in the -1. So we have -7 times a -1 is a +7. Let's move the 7 to the other side by subtracting 7 on both sides. So 3 minus 7 gives me a -4. Now to solve for x, I'm going to divide both sides by 2. So -4 divided by 2 is a -2. So the solution set for this linear system is -2, -1. Okay? So as you can see, the addition method or elimination method, it's a little bit more work, but they both work. Okay? All right, let's try it one more time. Let's practice using any method, but again, let's practice the elimination by addition method. Okay, so we have these two equations. Again, let's eliminate the x again. So we have the same scenario again. These two equations, the x has a different sign, so all I have to worry about the value. So on this particular one, I'm only going to have to multiply the first equation. So in order for me to eliminate the x, I can make this 2x into a 4 by multiplying the whole equation by 2. So on this one is a little bit easier because I only have to multiply a number to one of the equations, and it's going to be the first one. So let's go ahead and multiply my first equation by 2. So 2 times 2x is going to give me the 4x. 2 times a negative 5y is going to give me the negative 10y. And then 2 times 6 is equal to 12. So let's go ahead and add the two equations. I'm going to add the 4x minus 10y equals 12 with the negative 4x plus 10y equals negative 1. Okay, let's do this. And when I do this, my x is canceled, but my y is also canceled. So when I add the numbers, 12 minus 1 gives me a negative 11, but negative 11 is not equal to 0. So when this happens, when you have an equation, when you're solving the linear system, and you do not get a true solution, meaning that this is not equal to that, then that means that there is no solution, that this is an inconsistent system. This means that these two lines never intersect. They don't cross, okay? All right. So let's look at a word problem now, okay, to show that we can use solve using linear systems. Okay, so we have this word problem. Let's go ahead and read it. The given amount of annual interest is earned from the total of a $9,000 investment in two funds paying simple interest. Write and solve a system of equations to find the amount invested at each given rate. Okay, so they're giving us two investments. Both of the investments have different rates. One of them has a 2%, one of them has a 6%. We have an annual interest of $380, and we know that we're going to have a total of $9,000 invested between these two interests. So let's do a little review too. So we know that when we add the two investments, they're going to give us a total of $9,000. And we know that investment A is at 2%. We can call A, be this rate 1, 2%. And we can do investment B is a 6%. That's what's given. So we know from what they gave us that when we add investment A with investment B, has to give us a total of $9,000. Now, the second equation, okay, this is to get total. It's price times quantity. You can think of it that way. So we have a rate for A is at 2%. So the rate times the value of A plus the rate of B, which is 6%, I'm converting into decimals, times B should equal our annual interest, which is the 380. So this is to get our total interest by adding the two interests separately, yes? All right, so we can see here, now we have two equations with two unknowns. So now we can either do the substitution method or elimination method to solve, okay? So let's go ahead and, to make our math a little bit easier, to not deal with the decimals, let's go ahead and multiply equation 2 by 100. This is to eliminate the decimal, okay? So when I do the multiplication of 100, again, I gotta make sure that I multiply to my whole equation, to both sides of the equal sign. So 100 times 0.02 is 2a, 100 times 0.06 is 6b, 100 times 380 is 38,000, yes? All right, so now let's go ahead and do the elimination method. So what we're going to do is we're going to multiply equation 1 by a -2. And when I do that, what I'm going to eliminate are the a's. You see, I hope you see this. So let's go ahead and do that. Let's go ahead and multiply equation A by this -2. So when I do that, I have -2 times A is -2A, -2 times B is -2B, -2 times 9,000 is a -18,000. So the elimination method, now I'm going to add these two equations together. -2a plus 2a, 0, it canceled out or eliminated. -2b plus 6b is 4b, and -18,000 plus 38,000 is going to give me 20,000. So to solve for b, I'm going to divide both sides by 4. And when I do that, b is equal to 5,000. So now again, I'm going to do back substitution, and I can choose any other two equations, but I'm going to choose the easy one, the first equation. So B was 5,000, so I'm going to have A plus 5,000 is equal to 9,000. To solve for A, I'm going to subtract 5,000 on both sides. So 9,000 minus 5,000 is 4,000. So I did what the homework asked me. I first, based on the word problem, I created a linear system, okay, for the two equations, and I used my elimination method to solve both equations. So the solution set for these two equations, or the value for investment A is 4,000 and the value for investment B is 5,000. Okay. All right. So let's look at nonlinear systems. So nonlinear systems are these that we were talking about. These are the ones that we're not looking at two lines like this one. This one was a linear system. I had two lines, but these are nonlinear systems because I have on one of them is a parabola, and that came from this quadratic equation. Same over here. I have a quadratic equation with a line. Okay. All right, so let's go ahead and look at this particular example. You see that one of them is a line. I know that my second equation is a line because my exponents are all 1, but this first equation, I have a quadratic. This x has a square in it, okay? So since there's no equation or variables, let's go ahead and use the elimination method since we didn't solve for any of them. Now, again, we could, but let's practice using the addition by elimination method. So let's change it around. Let's go ahead and eliminate the y's. And this one's easy to eliminate because if I add them without having to multiply any values to them, I'm going to go ahead and eliminate my y's right off the bat. So let's go ahead and add these two equations together. And when I add x squared minus 4 plus 4x, it's just going to give me x squared plus 4x minus y plus y. It cancels or eliminates at 0. And then 0 plus 0 is equal to 0. So now I have a quadratic, yes? So what we can do is we can use a quadratic equation. Or we can factor actually. Let's factor better. So let's go ahead and factor. We can factor out an x, so we have x times x plus 4, and we can use our 0 property that for us to get 0 here, either x has to be 0 or x plus 4 has to be 0. So one of our values could be 0 or one of the values could be -4. And here is just solving for x. Subtract 4 on both sides. So we have two values that we can have for x. We got to check these. Okay. So let's use x first. So when we use x equals 0, let's plug it into our equation. So 4 times 0 plus y equals 0. So this one gives me y equals 0. Now let's use -4. -4 to the same equation. 4 times -4 gives me a -16 plus y equals 0. To solve for y, I'm going to add 16 on both sides. So on this particular question, we have two answers. We have two solutions. When x is equal to 0, y is equal to 0, that is a solution point. And when x is equal to -4, y is equal to 16. So this is another solution point. So when we have two answers, we call this a set. We have a solution set that we have 2 points that are going to give us a true answer for both of our equations to our linear system. Okay. All right. Let's go ahead and try it one more time. Okay. We can see that if we do the elimination method, let's go ahead and eliminate the y's. So what we can do is we're going to have to multiply one of them by a -1. Since both of them have the same sign, I need to multiply one of the equations by a -1 to change the sign. Okay, they have to be opposing signs. So let's go ahead and multiply the first equation by a -1. So when I do that, when I multiply -1 to the first equation, -1 times x gives me a -x. -1 times a -y gives me a +y. And then a -1 times a -5 gives me a +5. So let's go ahead and add these two equations together. X plus y equals -5. X squared minus y equals -6. So when I add x plus x squared, gives me x plus x squared plus y minus y. It cancels or eliminates 0. Then we have -5 minus 6 gives me a -11. So we have a quadratic equation again. So I move the -11 to the other side. Again, we can factor, but let's go ahead and use our quadratic equation to practice. And when we do this, we see here on our quadratic equation, our A was 1, our B was 1, and our C was 11. But when we see is here, we end up with a negative square root. And we know that a negative square root is going to give us an imaginary number. So on this particular example, we have a no solution. It's an inconsistent system. We don't have any real intersections of this line with this quadratic, okay, with this parabola. All right. Let's look at this one. Ms. Chuka, did you want to jump in or? Okay, I'll continue.
Sure,
All right.
I can work this one out.
Okay.
All right, so thank you. So here we're still working with a nonlinear system. In fact, what type of equations do we have? So if you look at the first one, can anybody tell me what, if you were to graph this, what type of equation would you get? And then the second one, what type of equation is the second one? So I'll give you a couple of seconds to think about what type of graphs we have. And you can just put it in the chat if you know the answer. Okay, Mr. Carizales, what is the first one? A circle. And we know it's a circle because of the exponents, right? The x squared and the y squared. So that means that we're going to have a circle. And then the second one, since the x is squared, but the y is not, then that tells you that it's going to be a parabola. So we might have a parabola like this, or it might be like this. So we're going to be looking for those solutions if they exist. Okay, so it's going to be up to each one of us to decide which method works best for you. And so in this situation, we're going to go ahead and use the elimination method so that we can get rid of these two, or the x variable. So in order to get rid of the x variable, I need to multiply the first equation by a -3. So if I do that, then I'm going to have -3 times x squared, which is -3x squared, -3 times y squared, which gives us -3y squared, and -3 times 25, which is a -75. Now that we have done this, we can take the new equation here, and we're going to add it to the second equation. And so you're going to see that we can eliminate the x variable because -3x squared plus 3x squared will be a 0. And then we have -3y squared minus 16y, -75 plus 0 will give us a -75. And again, this becomes a quadratic equation. And so at different methods to solve the quadratic equation, you can try to factor, or you can use the quadratic formula. Okay, so let's go ahead and look at this quadratic equation. The first thing we need to do is make sure that everything is on the same side. So I move the 75 over to the left side. And now we're going to use the quadratic formula. So I get negative times a -16 plus or minus the square root of b squared, in this case -16, minus 4 times a, which is -3, and c, which is 75. So if we simplify, negative and negative is +16, Negative 16 squared gives me 256. And negative 4 times negative 3 times 75 comes out to 900. So if I add what's inside the radical, I end up with 1,156. So the square root of 1,156 is going to be 34. So at this point, we can separate our answers, one for the positive and one for the negative. So my first solution would be 16 plus 34 divided by a negative 6. So 16 plus 34 is 50 divided by a negative 6. And if I simplify or reduce my fraction, then I'm left with negative 25 divided by 3. If we look at the second one, 16 minus 34 divided by a negative 6, then we're going to end up with a negative 18 divided by a negative 6, which becomes 3. So again, these two solutions are just coming from having this plus or minus after we took the square root. So now we can back substitute. And so first, let's look at the y equals 3. So again, you can use any of the equations. I'm going to go ahead and use the first one. So anywhere I see a y, I'm going to substitute y for 3 or 3 for y. So I end up with x squared plus 3 squared is equal to 25. So x squared is going to be plus 3 squared is 9 equals to 25. Subtract 9 on both sides. So we get x squared is equal to 16. In order to solve for x, I can take the square root on both sides. And so the square root of x squared would be x, and the square root of 16 would be plus or minus 4. So when y is 3, we get two solutions for x. So my order pair or my solutions here would be 4 and 3 and negative 4 and 3. But remember that for y, we had two answers. So we still need to check y equals negative 25 divided by 3. So if I substitute 25 divided by 3, and for all my y's, I get x squared plus negative 25 divided by 3 squared. So negative 25 divided by 3 squared is going to be 625 divided by 9. So if I subtract that, then I end up with negative 625 divided by 9 plus 25. So I believe this number here, if we divide it, it's going to be around 60 something, and it's going to be a negative. So we're going to end up with x squared. Let me just write it here. We're going to end up with x squared is equal to negative. I'm going to put a question mark because I'm not sure what that comes out to. But this value is going to be negative. And so if we take the square root, then we're going to end up with an imaginary solution because inside of here would be negative. And so now we're going to end up having a negative solution, which means that there's no real solution. So your only solution set for this problem is going to be what we got when y was equal to 3. So this solution for y gave us a no real solution. So we only stick with this as our answer. Is there any questions on that one? Okay. So let's try another one. Solve the system of equation using any method. So here, if since the x and y are being multiplied, it's going to make it a little bit hard to use the elimination method because of that multiplication. And so what we could use instead is use substitution. And you can choose to solve for any variable. I'm going to go ahead and solve for x in the first equation. And so if I do that, I'm going to add 1 on both. End up with x, y equals 1. And then I'm going to divide by y on both sides to give me x is equal to 1 over y, or 1 divided by y. So now I can substitute this into the second equation. So anywhere I see an x, I'm going to replace it with y, with 1 divided by y. So I get 3 times 1 divided by y minus 6y plus 17 is equal to 0. So if you don't like fractions, we can get rid of the fraction. Let me just simplify here first. 3y minus 6y plus 17 is equal to 0. So if I want to get rid of this fraction here, I can multiply by y all the way across. And so what we would have here is if we multiply all of this by a y, then we get 3 times, or y times 3 divided by y, which is just going to be 3. And y times negative 6y would be negative 6y squared. And y times 17 would be 17y. And y times 0, don't forget to multiply all the way across, so y times 0 would be a 0. And so if you notice, now we have a quadratic equation. So we're going to need to solve this quadratic equation. And so I'm going to use the quadratic formula. So here b is 17, so we get negative 17 plus or minus the square root of b, in this case 17 squared, minus 4 times a is negative 6, and c is 3. So if we simplify, then 17 squared is 289, 4 times 6 times 3, or I should say negative 4 times negative 6 times 3 is going to give me a positive 72. And if I add 289 plus 72, then I get 361. So we can break this up into two solutions, one for the positive sign and one for the negative sign. So we are going to end up with negative 17. The square root of 361 comes out to 19. So negative 17 plus 19 divided by negative 12 will give us 2 divided by negative 12. If we simplify this fraction, if we reduce it, then we end up with negative 1/6. And then for the second one, we get y equals negative 17 minus 19 divided by negative 12. So we end up with a negative 36 divided by negative 12, and that's going to give us a 3. So now we can back substitute. So first, we'll work out when y is equal to negative 6, or y is equal to negative 1 divided by 6. And so anywhere I see a y, I'm going to replace it by this. So I get x times negative 1/6 minus 1 equals 0. And there's different ways you can solve this. I'm just going to go ahead and multiply x times the 1. So I end up with negative x over 6. And I'm going to add the 1 on the right side. So I end up with 1. So to solve for x, I'm going to multiply by a negative 6. So negative 6 times negative 6 gives me a positive x. And 1 times a negative 6 gives me a negative 6. And then we need to check the second solution for y, which is y equals 3. So I'm going to replace my y with a 3. So I end up with 3x. Don't forget to add the 1 to the right side. And now to solve for x, I'm going to divide by 3. So x is equal to 1/3. So our solution set is going to be when x is negative 6, y is negative 1/6. So that's our first point. And then when x is 1/3, then our y is going to be the 3. So remember, these are the points where both of these graphs are intersecting. Okay. So these are considered nonlinear equations. And in the next section, you'll be graphing inequalities. But the process is going to be similar. But now you'll have to graph, instead of solving this way, you actually have to look at the graphs. Is there any questions? Okay, so for next week, we're going to be covering Chapter 8 topics. And I believe we only have 2 more sessions left. So we're going to be covering the Chapter 8 topics. And then the last session will be a review of everything to get you ready for your final exam. Okay. So if you do have any questions, we do have some tutors available, and they can assist you on a one-to-one basis. And so if you're interested in doing that, all you need to do is just let us know in the chat. And what happens is the tutor will go ahead and create a new room where they can help you as well. But thank you for joining us today, and we'll stick around. We still have a few minutes left. So if there is a question that you want us to work out, we can do that as well.
Thank you, Ms. Chuka. Thank you, Mr. Carrizales, for today's presentation. And as always, don't forget to sign in for today's attendance. I'll be stopping the recording now.